Okay, so today we're doing distance between 2 points. Okay, so we've talked about planes, we've talked about points and lines. Now we're going to be calculating distances between different points on planes and lines. So it first brings up a ruler, how to measure things on a ruler. Okay, we're not going to focus too much on that, but I do want to review. So where the big numbers are, where that 0 is and that 1, I'll zoom in. That 0 and that 1, those are what?
Inches.
Inches, good. What is this middle line in here? How much is that worth?
Half inch.
It's a ½ inch, okay? Now we move on to these in the middle of the half. What?
Centimeters. Fourth.
Nope, a fourth. You're close. A fourth, right? A fourth is right here. 3/4 is right here. Tricky question. What is the value of the little tick marks? Each tick mark, when you
Millimeter.
an eighth. Every time you move over in a ruler, it is 1/8. Okay? So, what is the whole measurement of that right there? What is the complete measurement from A to C? 2 1/4. Good. What about A to B? 7/8. Yep, it kind of covers it. I'm sorry. 7/8. Okay? Again, we're not going to spend a lot of time on that. Moving on to this example. It might be hard to see on yours, so look up here. It wants to know the distance between Albany and Athens. How do we find the distance between Albany and Athens?
80 and 90.
Yes, why do you add 80 and 90?
Because from Albany to Macon, it's 90 miles, and Macon to Athens is 80 miles, so add them together and get the whole number.
Good. Add them together. Thank you. So 90 plus 80. What's 90 plus 80? 170. What should we label that? Miles. Okay, moving on to the next one. This is what you're going to see a lot on your worksheet today. So, it wants to use the diagram to find EF. What does this mean, this line up here that gives you 16?
Total distance.
That's the total distance between D and F. So how are we going to find the missing part?
16 minus 10.
16 minus 10. The whole thing minus part to give you the other part. So what's 16 minus 10? 6. So whenever it gives you a line above the number line or the segments, that means that whole thing is that value. Does that make sense? Okay. This one I want you to try on your own real quick. Find AC and find ST. Go. Number 3, we want to find AC. It says AB is 14 and BC is 6. So how do we find the whole thing? Add them together. 14 plus 6. What do you get? 20. Number 4, we want to find ST. It gives you the whole segment, which is 23, and then it gives you TR, a part of it. How do we find the other part?
So, take 15.
23 minus 15. Always take that top number minus the bottom number, the part. What's 23 minus 15? 8. We got a couple more to look at here. Now we're looking at coordinate planes. We want to know if these lines, these segments are congruent. What does congruent mean? The same. Yep, you want them to be the same length to be congruent. How do we find the length of these lines? They don't have any values on them.
You count the squares.
Count the squares, okay? So I'm on D, and I'm starting here, and I count over. 1, 2, 3, 4. So that segment is 4. Now I'm going to start on F, and I'm going to count down. 1, 2, 3, 4. They are both 4, so what does that mean? They are congruent. So the answer is yes, they are congruent. Okay, try these last ones by yourself. Try these last ones quick and say if they are congruent, yes or no. Number 5, I'm going to start at A. I'm going to count over. What'd you guys get for that AB?
Yes.
5? What'd you get for CD? 5. So they're the same. So that would be yes. For 6, what'd you guys get for AB? When you counted them. Let's count 1, 2, 3, 4, 5, 6. What's DC? It is 6, so that means yes. What if one of them was 7 and one of them was 5? No, they're not the same, so they cannot be congruent. Good.